Chapter 2, Hyperbolic and Inverse Hyperbolic Functions. Hi everyone, Assalamualaikum. In this video, we are going to continue with Chapter 2, which is Hyperbolic and Inverse Hyperbolic Function. We still under Part 1, which is Hyperbolic Functions. Okay. Now we look one by one. Okay. We done discuss topic 1 and topic 2. Okay. We also done discuss topic 3, which is solving the hyperbolic equation using identities. Okay. So in this video, we will discuss how to solve hyperbolic equation using definition. Okay. Definition here means we will use this formula. Okay. Sinh x, cos x, and tan x in terms of exponential function. Okay. Alright, now let we look at some examples involving solving the hyperbolic equation using definition. We look at example 1. Solve the equation by using the definition of hyperbolic functions for cos x plus sin x minus 4 equals to 0. Okay. Alright, from the given question, okay, we have single x and single x, which is same angle. Okay. And there is no squares here. Okay. Alright, every time when we have same angle and no squares, we can solve the hyperbolic equation using definition. Definition here means we write in terms of exponential function. Alright. In the previous video, if the equation is given in terms of squares, we need to use identities. Okay. If the equation is given in terms of squares, never use definition or never use exponential function because it's hard to expand exponential function. Okay, to expand square. Okay, so if we have same angle and no squares, so we can solve using definition. Okay, alright, so from here, we can substitute cos x equals to e to the power of x plus e to the power of negative x over 2 and sin x here equals to e to the power of x minus e to the power of negative x over 2. Right? And then we have 4 here. We substitute cos x equals to e to the power of x plus e to the power of negative x over 2 and then plus sin x we replace by e to the power of x minus e to the power of negative x over 2 and then minus 4 equals to 0. Alright? Okay. And then we can simplify 4 and 2 here. Okay. But we still have denominator here. Okay. Because we cannot simplify here. Okay. So the best way is to eliminate denominator 2, we multiplying each term by 2. Okay. This is because we want to eliminate denominator 2 here. Right. So from the given function here, from the above function here, okay, we multiply each term 1, 2, 3, 4. Okay. 1, 2, 3, 4. Each term we multiply by 2. Okay. So after we multiply by 2, we can eliminate denominator 2 here and denominator 2 here. Okay. And after we simplify, so we get 4 no more over 2 and then times e to the power of x plus e to the power of negative x and then plus no more over 2 here and then e to the power of x minus e to the power of negative x and then minus, we solve here, so minus 8 and then equals to 0. Right hand side is still 0 because 0 times 2 equals to 0. Right? And after that, we expand, okay, one by one, okay, to eliminate bracket. Okay? So we have 4e to the power of x plus 4e to the power of negative x plus e to the power of x minus e to the power of negative x minus 8 equals to 0. Alright? And after that, we simplify. Okay? 4e to the power of x plus e to the power of x equals to 5e to the power of x. 4e to the power of negative x minus e to the power of negative x equals to positive 3e to the power of negative x. And then minus 8 equals to 0. Right? And then using the properties of indices, we can move down e to the power of negative x, okay, to denominator here. But now we have e to the power of positive x. We have same term now, okay, 5e to the power of x plus 3 over e to the power of x minus 8 equals to 0. And when we have same term, so we can write 5u plus 3 over u minus 8 equals to 0. Okay, where our u equals to e to the power of x. Right? And then from here, we want to eliminate denominator u here. Okay, so we multiplying each term by u to eliminate denominator u. Okay, so from here, we have 5u plus 3 over u minus 8 equals to 0. Now we multiply each term by u. We have 4 terms, 1, 2, 3, 4. Okay, so we multiply each term by u. Then we can simplify denominator u here and u here. So after we simplify, we get 5u squared plus 3 minus 8u equals to 0. Okay, 0 times u still equals to 0. And this is quadratic equation. So to solve quadratic equation, we need to rearrange, okay, based on descending power of u. Okay, so we start with 5u squared minus 8u plus 3 equals to 0. Okay, and then we need to factorize, or you can use calculator. U minus 1 times 5u minus 3 equals to 0. Right? Alright, from the previous slide, okay, we get u minus 1 times 5u minus 3 equals to 0. Okay, so after that, we equate each factor to 0. Okay, we have u minus 1 equals to 0 and 5u minus 3 equals to 0. Alright, then we find the value of u. U equals to 1. Okay, and then from here, from the previous slide, okay, we have u equals to e to the power of x. So we replace u equals to e to the power of x and then equals to 1. Okay, solve here means we want to find the value of x. Now our x in exponent. Okay, so we need to move e to right hand side. Okay, when we move e, base e to right hand side, okay, we have ln here. Okay, so left hand side we have x and then equals to, we move e to right hand side, so we get ln and then 1. Alright, so using calculator, ln 1 equals to 0. Okay, so we have x equals to 0. Okay, our value of x equals to 0. Right? And then the second factor, when we equate to 0, we have u equals to 3 over 5. And from the previous slide, our u equals to e to the power of x, okay, which is equals to 3 over 5. And using the same technique, okay, when we want to find the value of x, which is an exponent, okay, we need to move base e to right hand side. Okay, when we move base e to right hand side, okay, we will get ln. Okay, so now left hand side is x, and then equals to, after we move e to right hand side, so we get ln, and then 3 over 5. And then using calculator, x equals to negative 0.5108 up to 4 decimal places. Alright? If we want to check either the answer is correct or wrong, we can replace the value of x into this equation. If the value of x is correct, when we substitute in the left hand side here, so the answer we give 0, the value in the right hand side. Right? Got it? So this is the final answer. We have two values of x. Right? Alright, now we look at example 2 under solving the hyperbolic equation using definition. Solve the equation by using the definition of hyperbolic function 2 cos 2x equals to 1 plus 4 sin 2x. From the given question, okay, we have 2x and 2x here, which is same angle. And at the same time, there is no squares. Okay, so in this case, we use definition. Okay, and for this question, we not use double angle identities because the angles are same. Okay, we only use double angle identity if one of them is double and one of them is single. Alright, and if we have squares, we never use definition because definition means we write sin x and cos x in terms of exponential function. So if we have exponential function and squares, it's hard to solve. Okay? So that's why we only use definition when there is no squares and same angle. Right? So from here, we have sin 2x and cos 2x. We can refer from this basic formula, which is single x here. Okay? From this formula, if we have sin single x, the exponent also single x. Okay? And if we have cos single x, the exponent also single x. Okay? So from here, we can write 2. Now we have cos 2x. So we replace x here by 2x. So we get e to the power of 2x and then plus e to the power of negative 2x over 2. We still follow over 2, but we just replace x by 2x. Okay? And then equals to 1 plus 4. And then we replace sin 2x by e to the power of 2x minus e to the power of negative 2x over 2. We still follow 2 here, but we just replace x by 2x because now we have 2x. If we have both 3x, 3x, so we need to replace the exponent by 3x. Right? Alright, so from here, we have 2x. Okay? Exponent here equals to 2x because we have cos 2x and sin 2x. Okay? And after that, we can simplify 2 and 2 here and 4 and 2 here. So after we simplify 4 and 2, we get 2. Okay? We don't need to multiplying each term by 2 to eliminate denominator 2. Okay? Because we can simplify directly. Alright? Okay, so from here, we have e to the power of 2x plus e to the power of negative 2x, no more over 2, equals to 1 plus, after we simplify, we have 2 here, and then bracket e to the power of 2x minus e to the power of negative 2x, no more over 2, because we done simplify. And then we need to expand to eliminate bracket. Okay, so after we expand, we get e to the power of 2x plus e to the power of negative 2x equals to 1 plus positive 2e to the power of 2x, and then positive times negative equals to negative. So minus 2e to the power of negative 2x. And after that, we move all term to left-hand side. Okay? Then we get this. Okay? Then we simplify e to the power of 2x minus 2e to the power of 2x. 1 minus 2 equals to negative 1. Okay? Negative e to the power of 2x. And then this is same term. So 1 plus 2 equals to 3. So we have 3 e to the power of negative 2x minus 1 equals to 0. Okay? And then from here, we can use the properties of indices. So we can write 3e to the power of negative 2x in terms of 3 over e to the power of 2x. We move down using the properties of indices. So now we get positive exponent. Okay? And now we have same term. Okay? E to the power of 2x plus e to the power of e to x minus 1 equals to 0. So when we have same term, we can write minus u plus e over 3 over u minus 1 equals to 0. Okay? Where our u equals to e to the power of 2x. Right? And then from here, to eliminate denominator u, we can multiplying each term by u. Okay? So from here, we have 4 terms. 1, 2, 3, 4. Okay? We multiplying each term by u. Okay? So we can eliminate u here and u in denominator. Then we simplify. So we get negative u squared plus 3 minus u equals to 0 times u still equals to 0. Okay? Then we need to write coefficient of u squared equals to positive. So we multiplying each term by negative 1. Okay? So we get u squared, positive u squared, and then negative times negative equals to positive u. Positive times negative equals to negative 3 equals to 0 times negative 1 still equals to 0. Right? So we get this quadratic equation. Alright? Alright, from the previous slide, we get u squared plus u minus 3 equals to 0. This is irreducible quadratic equation. Okay? Means we cannot factorize this quadratic. So we can find u using calculator. Okay? So using calculator, u equals to 1.3028 up to 4 decimal places, and u equals to negative 2.3028 up to 4 decimal places. Okay? And then from the previous slide, our u equals to e to the power of 2x. Okay? Which is equals to this value. Okay? And then we want to solve, means we need to find the value of x. Okay? Now our x in exponent. So we need to move e to right hand side. When we move e to right hand side, okay, we have ln. Okay? Now left hand side, we have 2x equals to, we move e to right hand side, we get ln here. So we have ln 1.3028. Okay? And then x equals to ln this value and then over 2. Okay? Don't forget to divide by 2. Okay? So we get x equals to 0.13225. Alright? So ln here, we divide by 2, so we get this value. Okay? And then the other one, from u equals to this value, we replace u equals to e to the power of 2x. Because from the previous slide, our u equals to e to the power of 2x. And then using the same technique, okay, we need to move e to right hand side. Okay, And when we move e to right hand side, we get ln here. Okay? But ln negative is error. So when error divide by 2, so still give error. Okay? The calculator will appear met error. Okay? The screen calculator will display met error. So we can write undefined. Okay? Means no solution. Okay? So in this case, we only have one value of x. Okay? It is 0.13225 up to 5 decimal places. Yeah? To check whether this answer is correct or wrong, you can substitute this value into, let's say, into left-hand side function, and then we substitute into right-hand side function. Then we compare. The value on the left-hand side should be equals to the value on the right-hand side after we replace the value of x here. Okay? If the value of left-hand side not equals to the value of right-hand side after we replace this value, means that the answer is wrong. Right? You got it? Alright, how about example 3 under solving the hyperbolic equation using definition? Okay? Solve the equation by using the definition of hyperbolic functions. 2 cos 4x minus sin 4x equals to 2e to the power of negative 4x. Alright, from the given question, we have 4x and 4x here, which is same angle and at the same time no squares. And also, we have e to the power of negative 4x here. Okay? In this case, we need to use definition. Okay? Definition means we use in terms of exponential function. We use definition when we have same angle and no squares. Okay, now we have e to the power of negative 4x here. So this is also the reason why we need to use definition, because this is given in terms of exponential function. Alright? So from sin x and cos x formula, under definition of hyperbolic function, okay, we can write 2 times, we write cos 4x equals to e to the power of 4x plus e to the power of negative 4x and then over 2 minus, we replace sin 4x equals to e to the power of 4x minus e to the power of negative 4x over 2 and then equals to 2e to the power of negative 4x. We just follow here. Okay? So from here, we replace 4x here. Okay? We replace into here because this is formula for single x. Okay? So now we have 4x. Okay? Alright, from here, we can simplify 2 and 2 here, but we cannot simplify over 2 here. So, the best way to eliminate denominator 2, we multiplying each term by 2. Alright? So, from here, okay, we have 1, 2, 3 terms. So, now each term we multiply by 2. Okay? So, after we multiply by 2, we can simplify denominator 2 here and denominator 2 here. Okay, so after we simplify, so we get this 2e to the power of 4x plus e to the power of negative 4x, no more over 2, and then minus e to the power of 4x minus e to the power of negative x, must put in bracket because we have minus sign here, okay, and no more over 2. And then equals to 2 times 2 equals to 4e to the power of negative 4x. Alright? After that, we expand to eliminate bracket. Okay? So after we expand, we get this. 2e to the power of 4x plus 2e to the power of negative 4x and then minus e to the power of 4x and then plus e to the power of negative for x, and then we move right hand side to left hand side. So we get minus 4e to the power of 4x equals to 0. So now right hand side equals to 0. Okay. So from here, we can simplify. Okay. 2 minus 1. Yeah, this is the same term, the orange color. 2e to the power of 4x minus e to the power of 4x. 2 minus 1 equals to 1. E to the power of 4x. Okay. And then from here, we have same term. 2 plus 1 equals to 3 minus 4 equals to negative 1. So we get negative 1 e to the power of 4x. Okay, equals to 0. And then from here, we can use properties of indices. So we can write e to the power of 4x minus, we move negative exponent down. Okay, using the properties of indices. So now we have positive exponent. So we have minus 1 over e to the power of positive 4x. Now we have same term containing e to the power of 4x. So we can write u minus 1 over u equals to 0. Okay, where u equals to e to the power of 4x. Right? And after that, to eliminate denominator u, we need to multiplying each term by u. Okay? We have 3 terms, 1, 2, 3. So we multiply each term by u. So we can simplify this denominator. So after we simplify, so we get u squared minus 1 equals to 0. Alright? Then we can factorize. Okay? U plus 1 times u minus 1 equals to 0. Right? Alright, from the previous slide, we get u plus 1 times u minus 1 equals to 0. Then we equate each factor to 0. So we have u equals to negative 1 and u equals to 1. Okay? And from the previous slide, our u equals to e to the power of 4x. Okay? And then we equate to negative 1. Okay? And then, now we want to solve. Solve means we need to find the values of x. Okay? And x now in exponent. So to solve exponent, okay, we need to move e to right hand side. Okay? After we move e to right hand side, so we get left hand side for x equals to ln and then negative 1. And ln negative is error. So error divided by 4 equals to error. Okay? When we solve ln negative 1, your calculator will display math error. So we can write undefined. Right? Right. How about u equals to 1? Okay? In the previous slide, our u equals to e to the power of 4x. So we equate to 1. Okay? And using the same technique, we move e to right hand side. Okay? Then left hand side, we get 4x equals to, after we move e to right hand side, we get ln. Okay? And ln 1 equals to 0. 0 divided by 4 equals to 0. Means that x equals to 0. Right? We divide by 4 here. Okay? So to check the final answer, you can substitute 0 into left hand side. And then you substitute 0 into right hand side. If the answer from left hand side exactly equivalent to the answer on the right hand side, means that the answer is correct. Alright? You got it? Coming up next, derivatives of hyperbolic functions. If you like this video, you can subscribe. Thank you for watching. Stay tuned. Bye. Assalamualaikum.